Okay, so let's do some of the questions on the review together. So the first set of questions says solve each system by graphing and then check. So what we got to do here is they're giving us two different lines, and if they asked us to solve by graphing, we got to see where these two lines intersect, and that ultimately gives us the solution. So if I ever ask you to solve by graphing, the most important step is this. You got to make sure your equations are in slope-intercept form. You got to make sure that they follow this format of y equals mx plus b. When your equations look like that, they are so much easier to graph. So if we look at both of these equations and we look at the first one more specifically, we'll notice that it is already in that slope-intercept format. Okay, this is already easy to graph. It's easy to tell me what my y-intercept is, and it's easy to tell what the slope is. So your y-intercept is always what's in the b spot, whatever is written last, the last number. So for this example, b is equal to 1. I know it's going to intersect the y-axis at positive 1, which is right here. This is one of the points on that first line. And then the slope is whatever is in for m, whatever the number is next to the x. In this case, m is equal to -2, or -2/1 more specifically. The slope of this line is the rise over the run, which is -2/1. So from this point, what I'll do is I can go down 2, 1, 2, and then over 1 to the right. And that pattern can continue forever and ever. I could keep going down 2, 1, 2, and then over 1 to the right. Down 2, 1, 2, over 1 to the right. So if I connect the dots here, your line should look something like this. It might not be perfectly straight. Sorry, I'm on the computer, so it's a little bit difficult for me to make nice lines. But it should look something like that. The line is going down and to the right and starts at positive 1. Okay, but when we look at the second equation, this one's a little bit more difficult because it's not in that slope-intercept format. It's not in the format y equals mx plus b. So we got to rewrite it. If I give you 4x plus 2y equals 2, your job is you need to rearrange this equation so it's in the format y equals mx plus b. We want to get y all by itself. So if our goal here is to get y all by itself, the first thing I would do is I got to move this 4x. I'm going to subtract 4x from both sides. It's a positive 4x. So I subtract 4x from both sides. On my left side, I'm just left with 2y. And on my right side, to make it look like mx plus b, I'm going to write the x term first. I see negative 4x, so it's negative 4x, and that's a positive 2, so it's going to be a plus 2. Okay, so I'm a little bit closer. Then I ask myself, is y all by itself yet? No, it's not. There's a 2 still next to it. I got to get rid of that multiply by 2. How do you get rid of multiplying by 2? You have to divide by 2. But here's the tricky part. If I divide my entire left side by 2, I got to make sure I divide my entire right side by 2. Every single piece on my right side needs to be divided by 2. So when I simplify this, or it should be negative 4 divided by 2, which is negative 2x, plus 2 divided by 2, which is plus 1. Okay, so now I did all of that work, so now this is in a form that is easy to graph. This is the exact same thing, 4x plus 2y equals 2, is the exact same thing as negative 2x plus 1. Now that it's in a form that's easy to graph, what do I notice? I notice that this is the exact same thing as this equation up here. They're both y equals negative 2x plus 1. So what happens is when I graph this thing, I'm going to realize it's basically just two lines that are stacked directly on top of each other. Okay? Now, what does that mean? If you ever have two lines that are stacked directly on top of each other, they're crossing in infinitely many places. If they're crossing in infinitely many places, what do we say our answer is? We say our answer is infinitely many solutions. There's infinitely many places where they cross. There's infinitely many solutions. Okay, now if we look at example 2, a little bit more straightforward. But what's nice about this one is that both these equations are already in slope-intercept form. For this first equation, b is equal to 2. The y-intercept is equal to 2, which is up here. and then my slope is negative 3 over 1. So from this point, my rise is negative 3. I go down 3, 1, 2, 3, and then over 1 to the right. I'm always going to the right. Down 3, 1, 2, 3, over 1 to the right. Play connect the dots, and your line should look something like that. Okay, now do the exact same thing with the other equation. I'll change colors here. For this one, b is equal to negative 3, and then my slope is equal to 2. So I start at negative 3, 3 units down. And then my slope is positive 2, or 2 over 1. So from that first point, I'm going to go up 2, 1, 2, over 1. Up 2, 1, 2, over 1. And now my job is this. I'm going to sketch this line. It should look something like that. Not a perfectly straight line, sorry about that. But my job is to check, okay, where do these two lines cross? At what point do these two lines collide? And it looks like it's right about here. What is the coordinate for this point right here? It looks like it's 1 unit to the right and 1 unit down. So my guess for where those two lines collide is the point 1 unit to the right, x is 1, and then 1 unit down, negative 1. That is my guess for the solution, but it's always a good idea to check to make sure that it meets both equations. It is correct for both equations. So all you got to do is plug these numbers into these equations to make sure it spits out a true statement. So y is equal to negative 1 and x is equal to positive 1. Let's plug these in just to make sure. Does negative 3 times 1 plus 2 equal negative 1? Negative 3 times 1 is negative 3. Does negative 3 plus 2 equal negative 1? Yes, it does. So that one checks. Then do the exact same thing for the other equation. Plug in 1 for x and negative 1 for y. Does negative 1, sorry, I'm going down here, equal 2 times 1 minus 3. What's 2 times 1? 2. Does 2 minus 3 equal negative 1? Yes, it does. This also checks. I know 1 comma negative 1 is the solution to this question.